Okay, fractions. Here we go. Anybody already get an answer for this?
I said 4 going to 5 once.
No, this is
1 goes to 3, 3
Don't you cross like
good guess. But yeah, we're gonna do a little bit of cross something.
Cross
So no,
multiply.
it's not 4 goes into 5. We not dividing here. We doing fractions. Let's start with some steps, because if you have a formula, sometimes that makes it a little easier to remember. So, anybody remember the first step you always take when you're trying to solve a fraction? No. Okay. It starts with, well, I'll just tell y'all for the sake of time. We're gonna look for the common what? Denominator. See? All right, so step 1, find common denominator. And different teachers honestly teach different ways to do it, but using the steps I'm going to teach you today, I've had one of the highest passage rates in math at the different schools I've taught math at. So just go with me on this. I'm going to break it down into about 3 steps, and you will get it and you will pass this test. All right, so find the common denominator. Which number is the denominator, the top or the bottom?
the bottom.
The bottom. All right, so the denominator or common denominator means both of these bottom numbers can do what? Anybody know? Okay, both of these bottom numbers would be able to divide evenly
Onto each other.
into the new denominator. So to make, for the sake of time, what number can both 3 and 5 go into?
1.
No, 5 can't go into 1.
Sorry.
6.
Not 6.
I mean,
All right, let's
hold
do
on,
this. I'm gonna tell y'all a quick way to figure it out. Just multiply the 2 bottom numbers times each other, 15, because you know that both of them can go into it evenly, right?
Mhm.
All right, so we're gonna put a 15 over here, and that's gonna become our new what?
Denominator.
Common denominator. Because why is it common again? They can both what?
Go into each other.
Go into the 15 evenly. So we're gonna have,
Like Ison.
yes.
Disappear.
I think this pen work. Yep, here you go. Okay, so our job, since we know what the common denominator is to turn our old denominators into the new denominator. So, what type of sign is this?
Multiplication.
Multiplication. So, okay. Should I make y'all guess? No. What time is it? All right, lunch in 15. Just bear with me. Okay, so we're gonna try to turn this 5 into a 15. 5 times what equals 15? 3. All right, so that leads to my second rule, because we're doing this. 5 times 3 is 15, but it's blank right here. So my second rule is this: whatever you do to the top, do to the bottom. And I'm gonna have to abbreviate a little bit. Whatever you do at top, comma, do at bottom. So if I took this 5 and multiplied it by 3, what am I gonna do up here to the 4?
Multiply.
By what?
3.
3. Because whatever you do, what's rule 2?
Whatever you do at the top.
All right, so then it's gonna be 4 times 3.
12.
So we've converted 4/5 to what?
12.
12 over 15, because we multiply both numbers by 3. All right, so at the bottom, what are we turning our 3 into? 15. What do we do to turn the 3? 3 times what? 5. Thank you, Mary. All right, so 3 times 5 gives us 15.
So then what you do?
What's rule 2?
Do
Yeah.
whatever you did to the top to the bottom. So what did you do 1 times 5.
1 times 5. All right now, Mary. 1 times 5 gives us what?
5.
5. All right, so what type of problem is this? What's our symbol?
Subtraction.
Subtract. What's our final answer?
We trying to top and the bottom together.
7.
7 over 15. All right, so I'm gonna put here solve problem, and it sounds like common sense, but sometimes when people finish doing all this, they tired and they forget you need to finish solving the problem. So we're not gonna stop with 12 over 5 and 5 over 15. We're gonna subtract because this is a subtraction problem, and this is gonna be our final answer, 7 over 15. All right, how was that?
Fine, don't.
That one was cool. I like it that one.
Okay.
I just needed that. Work on that.
Just the division. Okay, you got the fractions? Okay. I want to do at least 1 or 2 more fractions before I totally stop, because I know this is definitely on the final exam. So let's do 1 more and then we off to lunch. Let's see. I'll make the next one addition. So let's go 1/4 minus 1/3.
Okay.
All right, so what's step 1?
Multiply the two denominators.
Multiply the two denominators, to find what?
The common.
Find
What
the
goes
common
into both?
denominator.
What goes into it both at the end of it? So it'd be 12.
Yes, ma'am. It's 12.
And then you would do it like, the first one you would do, 4 goes into 12 3 times.
So 4 times
3.
3 gives us our 12. All right, what's rule 2?
Whatever you do to the top.
Yeah,
Whatever you do to the,
to the bottom.
Ooh,
to
and
the
I'm-
top.
I said that backwards. So this gonna look ugly, but it's actually whatever you do to the bottom, do to the top, because you do the bottom first in most cases.
Right.
So
So then you would do 4 times
4 times 3 is 12, and then 1.
1 times
4.
1 times 4. No, 1
I mean, 1 times 3. I'm sorry.
1 times 3 is 3.
All right, so 1 times 3, that's correct, is
Then
3.
for the bottom one, you would do 3 times 4 equals 12. And then you would do 1 times 4 equals 4. For the top one. And then it would be,
Oh, I said this was gonna be addition, I'm sorry.
would it be 7 over 24?
Nope.
Or 7 over 12?
Yeah, you don't,
7 over 12.
Oh, you don't change
don't
the bottom.
the
You
denominator.
just change the top.
yeah, that's right. It's, you never add these, so it wouldn't be 7 over 24. We're looking for what in the first place?
The common
Yeah, we did a lot of work to make sure the denominators were the same. The reason is you can't add them if they have 2 different denominators. It's like trying to add apples and oranges. You need to add the same thing to produce or multiply or go further. All right, so we found our common denominator and it stays the same even all the way down to the bottom. And then this was an addition problem, so 3 and 4, you guys are correct. The final answer is 7 over 12. Oh, my babies. Okay, it is now
Yeah, like, yeah, wait for me.
12:03. We might as well round to 12:05. I will see you guys at 12:35.
You will see me there.